come on! What happens to a dead satellite? Right now, over 2,700 decaying machines are screaming around Earth at 17,000 miles per hour, each one a potential wrecking ball. This is the most valuable and dangerous scrapyard ever created. If one fragment hits the wrong spot, it could trap us on our own planet. I am about to show you the billion-dollar race to melt those corpses down into brand new rockets. Here we go. This isn't science fiction. The chain reaction already started in 2009 when two satellites collided, creating 1,800 new bullets. Today, every weather forecast, bank transaction, and ride you order relies on satellites flying blind through this junk cloud. The question isn't if another catastrophic collision happens, it's when. And the answer is buried in how we turned our orbit into a ticking time bomb. To understand how we got here, you have to go back to 1957, when Sputnik first pierced the sky. Back then, space was empty, infinite. We threw things up there and never thought about what happened when they died. For 6 decades, nations and companies kept launching. Geostationary satellites for television, GPS birds for navigation, spy satellites, weather monitors, and when the fuel ran out or the electronics fried, we just abandoned them. They became ghost ships drifting through the most hostile environment humans have ever engineered. The math got ugly fast. The European Space Agency now tracks over 54,000 objects larger than a golf ball, each one traveling 17,000 miles an hour. At that speed, a fleck of paint hits like a grenade. A dead satellite, the size of a school bus, carries the kinetic energy of a freight train. But here is the thing that keeps mission controllers awake at night. The real danger isn't the big objects we can see. It's the 130 million fragments too small to track, spawned every time two pieces collide. That's the chain reaction Donald Kessler warned about in 1978. Collision creates debris. Debris creates collision. Eventually, low Earth orbit becomes a wall of shrapnel, making spaceflight impossible for generations. Kessler syndrome. In 2009, the warning became real. A defunct Russian military satellite, Cosmos 2251, slammed into Iridium-33, an active communications satellite. Two perfectly functional orbits collided at 26,000 miles per hour. The impact vaporized both spacecraft, scattering 1,800 new pieces of tracked debris across the northern sky. For the first time, we had activated a bomb we couldn't defuse, and that was before the mega constellations. Before SpaceX alone launched over 5,000 Starlink satellites in 4 years, with plans for 40,000 more. Every single one has a 5-year expiration date. After that, it becomes more debris unless we have a plan. Which brings us to the scrapyard solution and the terrifying reason it might already be too late. The scrapyard isn't on the ground. It's 100 miles above your head, and it's not a place. It's a process. Since 2018, a small group of engineers backed by the European Space Agency and a handful of private companies have been quietly building the machines that will chase down dead satellites, grab them, and melt them into something new. Their first prototype was called Remove Debris, a 100-kilogram satellite built by Airbus with one simple mission: prove that capturing junk in orbit was even possible. In 2018, it launched from the International Space Station and deployed a net. A net. Like something you'd use to catch a fish, except it was flying at 17,000 miles per hour and targeting a small CubeSat drifting in the void. The net snared it perfectly. Then the spacecraft fired a harpoon into a target panel, demonstrating a second capture technique. For the first time, we had tools that could physically grab hold of a tumbling, uncooperative object in space. That proof of concept cracked open a door that had been sealed since the dawn of the space age. But here is the problem nobody wants to talk about. Grabbing a satellite is just the first step. A dead satellite weighs anywhere from a few hundred kilos to several tons. To get meaningful metal out of the scrapyard, you need to do more than drag debris into a lower orbit and let it burn up. You need to dismantle it, sort its materials, and process them into feedstock in microgravity. And that, until now, has been considered science fiction. Enter Dexter. In 2025, a consortium of universities and companies from the UK, Spain, Estonia, and Sweden launched a program with a radical goal: take apart an old satellite in orbit using robotic arms and laser cutters, then recycle its aluminium and titanium on the spot. The idea is that metal alloys could be ground into powder and fed into a 3D printer, building new satellite struts or antennae right there in space. Organic materials and leftover fuel could be heated, the gases captured and reused as propellant. Nothing wasted. A dead satellite becomes a gas station and a hardware store, floating precisely where you need it most. The economics are staggering. It costs roughly $10,000 to launch 1 kilogram of material into low Earth orbit. A typical communications satellite contains hundreds of kilograms of aluminium. By recycling just a handful of derelict spacecraft, you could save tens of millions in launch costs alone. And that's before you factor in the rare metals, gold in connectors, platinum in thrusters, indium in solar panels. Right now, estimates suggest there are 6,000 tons of refined materials orbiting Earth in the form of dead satellites, worth billions of dollars at ground prices, but essentially free for whoever can process them first. But there's a pivot that changes everything. This isn't just about cleaning up our mess. It's about who controls the supply chain. If a single nation or corporation masters orbital recycling, they won't just remove debris. They'll control the raw materials for the next generation of space infrastructure. They'll build reconnaissance satellites from salvaged metal without ever launching a single rivet from Earth. They'll deny competitors access to the very resources floating overhead. The scrapyard isn't just an environmental crisis. It's the next battlefield, and the weapon is a recycling plant. Which brings us to the terrifying reality. The tech is still years away from working at scale. Remove debris burned up in the atmosphere after its test. Dexter is only a ground simulation so far, and every month we delay, another 40 or 50 new satellites are launched into already crowded orbits. In 2026, a defunct Russian upper stage narrowly missed a cluster of Starlink satellites by less than 60 meters. A fraction of a second difference, and the cascade could have begun. The machines we need to stop it are still being invented, and the fuse is already burning. That 60-meter miss in 2026 wasn't an anomaly. It was a warning shot. The real headline isn't the 54,000 objects we can track. It's the 130 million fragments we can't. Each one, a tiny, unseen missile. And here's the part nobody expected. Even if we stopped every single launch tomorrow, the debris already up there would keep multiplying. The European Space Agency's 2025 report confirmed that collision risk in low Earth orbit jumped 20% in a single year. The cascade has started. We just can't see it yet. But wait, it gets worse. The most dangerous objects aren't the dead satellites. They're the abandoned rocket upper stages, dozens of them, each containing leftover fuel that can spontaneously explode after years in orbit. That's how the Russian Cosmos satellite broke apart in the first place. And those are the ones we're supposed to somehow catch and recycle. The world's response so far has been a patchwork of regulations. The FCC now requires US licensed operators to deorbit their satellites within 5 years of mission end. Groundbreaking. Except it doesn't apply to the thousands of legacy objects already up there. And it doesn't bind China, Russia, or India. For geostationary satellites, the solution is a graveyard orbit, a cosmic parking lot 300 kilometers above the busy highway, a place where old birds are sent to die, drifting forever. But that graveyard is filling up too, and it only takes one nudge, one micrometeoroid impact, to send a drifting corpse tumbling back into the traffic below. So the pressure cooker is building. In 2021, a single Russian anti-satellite missile test added 1,500 trackable pieces in minutes. The United Nations banned such tests in 2022, but the debris remains, and the lesson is clear. The scrapyard isn't just an accidental mess. It can be weaponized by anyone willing to pull the trigger. Now, here is the pivot that changes everything I've told you so far. There is a hidden economic engine that could accelerate the cleanup. The very threat of Kessler syndrome has created a new asset class: Companies like Astroscale and ClearSpace are signing contracts worth hundreds of millions of dollars to develop debris removal services. Their business model: governments will eventually be forced to pay them per object removed, or sell removal credits the way we sell carbon offsets. And the first nation to prove it works won't just clean the sky. They'll own the monopoly on orbital logistics for the next 50 years. That's why the engineering race is already underway, in secret. The Dexter Consortium isn't just building robotic recyclers for academic glory. They're designing the machinery that will literally melt down a captured satellite, separate the aluminum from the titanium, and feed it straight into a 3D printer that builds a new satellite on the spot. No Earth launch needed. A closed loop in orbit. The cost of building in space drops to zero. But here is the terrifying knife edge we're balancing on. That future is still a decade away, minimum. And the next 1,000 satellites are launching in the next 18 months. The window to prevent a runaway cascade is closing faster than the rescue tech can be deployed. We are in a race where our starting pistol and the finish line are the same bang. Which brings us to the one person who saw all this coming 40 years ago, and the radical solution he's now proposing. It's not recycling. It's not nets. It's something so audacious, it might just work, or doom us faster. That person is Donald Kessler, the man who wrote the original paper in 1978 that no one wanted to believe. He's now in his late 80s, and he's done being patient. His new proposal doesn't involve nets or robotic arms or melting anything down. He wants to beam the debris out of existence, using a network of high-powered ground-based lasers tuned to strike the smallest, most dangerous fragments and vaporize them into plasma. Zap. Gone. No capture, no recycling, just a clean sweep of the invisible bullets. The physics is sound. A powerful enough laser can ablate a tiny area on a piece of debris, creating a micro-thruster that nudges it out of orbit or simply vaporize it entirely. The European Space Agency has already simulated this. A dedicated laser array could clear the 100,000 most threatening fragments in just a few years. The cost? Roughly the same as 2 or 3 failed satellite launches. But there's a catch, and it's the same catch that has haunted this entire story. If you aim wrong, if your laser pulverizes a large fragment instead of nudging it, you've just created 1,000 new pieces, each still moving fast enough to kill. You don't clean the scrapyard. You multiply it. That's why Kessler's solution remains on paper, and why the recycling approach is still the safer bet. For now. So here is where we actually stand. The space scrapyard is real, it's growing, and the machines to process it are evolving from harpoons and nets to full-scale orbital refineries. In the next 5 years, the first commercial removal missions will kick off. Astroscale's ELSA already proved autonomous docking. ClearSpace -1 is funded and scheduled to grab a derelict payload adapter. The infrastructure is being assembled. But it's not just about cleaning. It's about the wealth of 6,000 tons of refined metal drifting in the black, waiting for the first entity with the will to own it. That entity could be a nation, a corporation, or a consortium of visionaries who understand that the next industrial revolution isn't on Earth. It's above it. And here is the final detail that few people talk about. The same laser system that could clear debris could also mine it. By precisely zapping a dead satellite's hull, you can strip off thin layers of aluminum and titanium and collect the metallic dust in a capture net. Now, you've turned the scrapyard into a refinery beam. No robotic arms, no harpoons, just light and geometry. The race isn't about who cleans the sky first. It's about who masters the beam, because the scrapyard is just the beginning. The asteroid belt is next, and whoever controls the refining technology controls the resources of the solar system. That's the prize. Not just saving the satellites that deliver your internet, but owning the supply chain for space itself. The question is no longer whether we clean the sky, but who gets to write the rules when we do. Will it be a coalition of nations turning debris into a shared inheritance, or a handful of corporations mining the heavens while the rest of us just watch? The scrapyard has been growing for 60 years. Its resolution will define the next 60. If this story made you look up a little differently tonight, hit like and subscribe so you don't miss what comes next. because the machines that will change everything are being bolted together right now. I'll see you in the next one, and bye.